Hello, 7th grade math. Today we are on lesson 7.3, solving addition and subtraction equations. Please have your books open to page 327 to follow along. And the big term, maybe the most important term in math going here on out, that we're going to find in this lesson is inverse operations. I'm going to write it down here. It's found on page 327. Please take a look at it. Inverse operations refer to, well, remember first of all that we have four main operations in mathematics. We have addition, subtraction, multiplication, and division. Inverse operations refers to an operation that undoes what another one just did. So, in other words, the inverse operation for addition would be subtraction, the inverse operation for multiplication would be division, and vice versa going the other way. The inverse for division would be multiplication, the inverse for subtraction would be addition. Ultimately, the other piece that we're trying to come up with in this these examples that we're going to have today, we're trying to come up with what would be called equivalent equations. In other words, equations that have the same solution. The solution of the equation is the piece that you can plug in for the variable, and it would be the same thing. So in other words, what we're going to end up trying to do is we're going to have, like in example 1, we're going to have x plus 7 equals negative 10. This is a pretty somewhat complicated equation in as far as figuring out, well, what goes in place for x, what is the solution for this. But ultimately what we're going to try to do is we're going to try to come up with an equivalent equation in which the same value for x can be placed in there, and it's going to be equal to just one number, whatever that number is going to be. So we'll come back to that in just a moment after we do example 1, so you can see what I'm trying to say. So let's go ahead and do example 1 right away. In example 1, again, that equation that we were given is x plus 7 equals negative 10. And I myself, personally, this isn't from the book, but this is kind of how I handle equations. I've always handled equations like this and any other ones by asking myself the question, what's happening to the variable? So I've got a variable here, and it's being 7 is being added to it, or it's being increased by 7, however you want to say that. So understand that if I had the variable over here, 7, and I added 7 to it, I would land on negative 10. That's basically what's going on here. If that doesn't make sense, that's okay. Let's go ahead and look at it a different way too. What's happening to my x here? I'm adding 7 to it. So what I'm going to do is I'm going to use inverse operations to undo that adding of 7. The undoing operation would be subtraction, and I'm going to show it just like this. I'm going to kind of work my whole equation up and down vertically, okay? But here's the thing. I want you to think about this equal sign as a balance. If I do it to one side, I've got to do it to the other side. You can think of it literally as a teeter-totter here. You know, if I subtract 7 on this side, it's going to make this unbalanced. I've got to subtract 7 on this side to ultimately balance out my teeter-totter. What I want is I want my teeter-totter to be completely level. I don't want it leaning this way or the other way or anything like that. When I get an equation, I know that it's balanced. Even though it looks different on one side, it's balanced. So if I subtract 7 on this side, what I have to do is I have to subtract 7 on the other side as well. Okay? So now let's take a look at what ends up happening over here. Remember, we said that these were inverse operations. So adding 7 and minus 7, those are the inverse of each other. If I would add 7 to x and then I would subtract 7 from all of this, I end up right back at x. In other words, a positive 7 minus a 7 is 0. And I'm going to write this a couple different ways actually. The first way I would not actually write on my paper. I would say that x plus 0 is equal to whatever is over here. So let's take a look at what's over here. A negative 10 minus 7. It's like a negative 10 plus a negative 7. That's my rules for subtracting integers. They have the same sign. Therefore, it gets further negative. X plus 0 equals negative 17. Now, truth be told, and I don't think I'm shocking anybody here, but if I'm adding 0, that is literally doing nothing. So I don't actually even have to, when I do my inverse operations here, as long as I understand that adding 7 and subtracting 7 is going to end up resulting in that plus 0, I don't actually even have to write that. So if I get rid of this, what I end up with is x equals negative 17, which is ultimately what I want. So now I have two equations. One was the one that I started out with up here, x plus 7 equals negative 10, and the other one was the one that I landed on down here, x equals negative 17. These are the same. These are equivalent equations. That's that equivalent equation. Remember what I said I was going to have on this page. I said I was going to have x plus 7 equals negative 10 and x equals negative 17. If I plug a negative 17 in for either of these, I'm going to end up with a true statement. Negative 17 equals negative 17. Negative 17 plus 7 equals negative 10. They are the solution. Negative 17 is the solution to both of those equations. They are equivalent equations. All right. Now it's also good to check my work and actually just make sure that to make sure that I didn't do a stupid error somewhere, because it's easy to do. So I'm going to start back with my original equation, and I'm going to plug in for x what my solution was stated to be in my equivalent equation. So instead of an x, I'm going to have negative 17 plus 7 equals negative 10. And I'm going to ask myself, okay, well, what is negative 17 plus 7 then? I have a negative plus a positive. Therefore, I'm going to subtract the absolute value. 17 minus 7 is 10. And the greater absolute value belongs to the negative number, therefore it's going to be negative 10 equals negative 10. So long as I check my work and I have this number equaling the same number on the other side, that means that my work checks out and that I have done my solving of my equation correctly. So therefore x is equal to negative 17. That's the solution that I'm looking for on my paper. In example 2, we're going to take a look at some more inverse operations, but this time the difference is it's a subtraction problem. It's a subtraction equation, whereas here we had an addition equation. In other words, I was adding something to x, or I'm adding something to my variable. In example 2, we're going to start with a subtraction equation. I also want to point out in example 2 that in example 2 I have, it looks like the problem is backwards, and it's okay to do it this way. Don't freak out if you have what looks like the answer on the left side and the problem on the right side. These are two expressions. They are interchangeable. They can go on either side. Y minus 12 is equal to negative 9. The only thing I don't want you to do is I don't want you to think, oh, well, it's going this way, so I got to start from here and go this way. No, that's not true. You're always going to read it from left to right. So y minus 12, not 12 minus y. I don't think any of us will be doing that, though. So now I have, again, I have to ask myself the question, what is happening to my variable? What's happening to y in this situation? And I'm recognizing that it is being subtracted, or 12 is being subtracted from y. So the inverse of subtracting 12 would be adding 12. So I'm going to add 12 on both sides of the equation here. And I'm already noticing that I'm going to have a negative plus a positive. I'm going to have to remember my rules for integers. We'll get that. We'll do it. And I am also remembering, just like in my last problem, if I subtract 12 and then I add 12, I'm just getting back to where I began, which means that I would have a plus 0 or a minus 0 here. But what I can do, and I didn't do it on the other one, is I can just recognize if I have opposites here, I have a negative 12 and a plus 12, these are just going to cancel out. I'm just going to cross them out just to kind of notate that I've kind of taken care of that inverse operation there. And I'm left with y on the right side, and now I've got to do the hard part of the equation here. And I have to remember my rules for adding integers. So I have a positive and a negative. They're being added together. So I'm going to find the difference of their absolute values. The difference of their absolute values, 12 minus 9, would be 3. And then I'm going to ask myself, which one wins the war? Is it a greater positive absolute value or a greater negative absolute value? And the answer will be positive. Therefore, my y is equal to positive 3. And let's go ahead and check our work. Always good to check our work. Get in the habit of doing that. It will avoid just silly mistakes, and it'll help you avoid losing points on papers that really would have been easy to get. Okay, so in place of y, I'm going to put positive 3. And 3 minus 12, or 3 plus negative 12, I could rewrite that as 3 plus negative 12. I've got a negative plus a positive. Therefore, the absolute values, we need to find the difference. 12 minus 3 is 9. And the negative 12 is a greater absolute value, so therefore it's going to be negative 9 is equal to, and this just drops down, negative 9. So negative 9 is equal to negative 9. It checks out. Therefore, positive 3 equals y is my solution. Now, that is a correct answer. However, I encourage you, instead of writing it this way, I'd prefer you on your paper to write y equals, or the variable first, the variable equals, and then your solution. It's just a little bit better grammar in math, so to speak. Now, example 3, we see a situation in which we are asked to combine like terms first. So I have in example 3, 2 equals 1.3 plus a, that's my variable, plus 4. And I'm going to solve this equation. Eventually what I want to end up with is a equals blank, a number. But now I'm going to ask myself, what is happening to my variable? Again, that's the question I always want to ask. And I'm adding 4 to my variable, but I'm also adding 1.3 to my variable. Well, let's just go ahead and use the commutative property and say 1.3 plus 4 plus a. And once I use the commutative property, I could even go a little bit further and use the associative property if I wanted to, and just group those together. That would leave me with 5.3 plus a. Okay, and now and over on the left side of the equation, I haven't done anything with that 2, so he's just going to drop down. 2 equals 5.3 plus a is what I have. Now these two are the same equation. They are equivalent equations. I've simply combined my like terms, which we've done already. We've done that before. I've combined my like terms so that I have a much simpler task ahead of me. This looks a lot more manageable than this guy, and it's only a step away. So I'm going to go ahead and combine my like terms so that I only have one inverse operation to do. And I will notate that this is, well, I should say that this is a positive 5.3. And that's important to notate because in equations like this, well, there's a couple ways to look at this. If I have nothing but addition here, I could rename this a plus 5.3. Or I could just realize that if I have a positive here, it's going to work out this way. And the inverse of a positive is a negative, which is subtraction. Okay? So, and I'm going to do another example after this where it's the other way around. But the inverse of this positive 5.3 is going to be minus 5.3 or subtract 5.3. But if I do that to one side, remember I've got to keep my teeter-totter balanced here. So if I do that to one side of the equal sign, I've got to do that to the other side of the equal sign too. And it's going to get a little uglier on the left side of that equal sign. Remember, we can just cancel these out, leaving me with A. And over here, again, if I don't like 2 minus 5.3, I could add the negative. So to add the negative, I'm going to subtract the absolute values. 5.3 minus 2 is 3.3. And then it's got a greater absolute value on the negative number. The negative integer has the, or negative number I should say, has the greater absolute value. Therefore it's going to be negative 3.3 is equal to A. And we can go ahead and check our work. This one I might check with a calculator, which I don't have. So I'll let you do that. You can pause the video actually and just plug this in. 1.3 plus negative 3.3 plus 4, and you should come out with 2. Okay? I said I'd do one more, and I would like to do one more, and that is going to be, let's see here, how about I do 8 equals negative 6 plus m. Now I'm not combining like terms in this example, but what I wanted to kind of point out is that sometimes we have a little bit of a tricky scenario here because my question is, what is being done to m? And if it's written in this order where I have a negative integer plus the variable, sometimes people will miss this negative sign and they will kind of ignore it for the rest of the problem. Now, a couple ways to look at this is I could use commutative property here because I'm adding, and I could just rename this as m plus negative 6, which is a good option. Or I can remember that if I would do that, it would turn into this. Therefore, what I'm going to do for my inverse operation is, even though this is addition, I'm going to add 6, because that's going to get rid of adding a negative 6. Adding a negative 6 is very much the same as subtracting a positive 6. Therefore, the inverse of adding a negative 6 is adding a positive 6. If I add a positive 6 over there, I'm going to add a positive 6 on the left side just to keep my teeter-totter balanced. Again, always kind of visualize that teeter-totter. These guys cancel out, and I'm left with m on the right side of the equation, and on the left side of the equation I'm left with 14. So m is equal to 14. And you can go ahead and check your work on that. That'd be great. The last problem I'd like to do is the word problem found on page 329 in example 4. I'm going to read it out loud. Please follow along with me. It says the Apollo 11 mission lasted about 195.5 hours. The flight from Earth to the moon lasted about 103 hours, and the flight from the moon back to Earth lasted about 71 hours. About how many hours did the Apollo 11 astronauts spend on the moon? So what I have here is I have in the situation, I'm going to write a verbal model. So we have the length of the mission, the entire mission, which is equal to the length of the flight to the moon plus the time on the moon, and then of course we got to get back, so it's going to be the length of the flight back to Earth. So let's take a look at this again. The length of the entire mission is the length of the flight to the moon plus the time on the moon plus the length of the flight back to Earth. And so after I have a verbal model, what I'm going to do is I'm going to plug in the pieces that I do know, and then I'm going to solve for the pieces that I don't know. So let's see here. I know that the length of the entire mission, because it tells me in the book, is 195.5. And so I'm going to write that right underneath it. The length of the flight to the moon was 103 hours. I don't know the time on the moon, but I do know that the length of the flight back to Earth was about 71 hours. So the time on the moon is the missing piece. I need a variable for that, and I'm going to use the variable t for time. And I should notate that this is just kind of a little tip. If you ever use the variable t, I recommend that you use a little tail on it. Otherwise it looks too much like a plus sign, and you might confuse something in your homework. So now I have my equation. My length of the mission, 195.5, is equal to 103, the length of the flight of the moon, plus the time on the moon, t, plus 71, the length of the flight back to Earth. So in order to figure out the time on the moon, what I'm going to do is I'm going to solve. First of all, I'm going to solve for t, but first I'm going to combine my like terms. So again, using the commutative property, either in my head or on my paper, I can rearrange this side of the equal sign so that I have 103 and 71 right next to each other. It's still going to equal 190.